And the next speaker is Dr. Peter Fischer, so please come forward.
Well, thank you very much. I just wanted to Frauke Musial kindly commented on what I said. I just wanted to come back to her on one of the other reasons that she didn't mention, I think, why basic research is important, why it is important to look at mechanisms of action. And this is about what is called Bayesian statistics. Thomas Bayes was an English clergyman, actually. And he developed this statistical method that is based on what we call prior and posterior probabilities. So that means that you have a particular belief about a particular hypothesis. And in the case of most scientists in homeopathy, their prior probability is very low. And then you have evidence, and so the prior probability multiplied by the evidence gives you the posterior probability. And this is quite interesting. It can be expressed mathematically. Now this has some interesting implications, because if your prior probability, if your prior belief in homeopathy is 0, 1,000,000 times 0 is still 0. Nothing will ever change your mind. So this is actually quite important, because that puts you outside the realm of science. In science, you can propose anything you like if you can produce some evidence that it's true, but these people will say, whatever evidence you produce, I don't believe it. That is an anti-scientific attitude. So that is important. But if you look at the structure of the equation, in fact, we suffer a double problem. One is the prior probability, which for most scientists is very low. The other is the credibility of the evidence. So the credibility of the evidence and the strength of the evidence both come in. And if there is no plausible mechanism, then you're going to downgrade your belief in the evidence. So to think about it in a Bayesian way is interesting. And what it tells you, what it tells me, is that we need to somehow make the evidence more plausible. And for me, there's an interesting precedent in acupuncture. Acupuncture has come in from the cold in a big way. Now, NICE, this is a very powerful national institute we have in the UK, recommends acupuncture for back pain and headache. This would have been a heresy 20 years ago. Now it is recommended by the official UK body. And one of the big things I think that changed was the so-called gate theory of pain. The gate theory of pain that was developed by two people called Melzack and Wall. And basically what it says is that you have what they call collateral inhibition in the brainstem. Basically, if you have inputs coming from one place, they can close a gate in the back of the brain and stop pain impulses coming through. Now, that theory certainly isn't a complete explanation of acupuncture, may not be an explanation of acupuncture at all. May have nothing to do with acupuncture. The point is it's plausible. It is plausible to a conventional neurophysiologist. So they thought, well, okay, yes, that is possible, I can believe that. And so suddenly the plausibility of evidence about acupuncture changes. That yes, there is a thinkable, conceivable, plausible mechanism. So that is one of the reasons why we need to look a little bit at basic mechanisms. The other one is, frankly, it's fascinating. It is really interesting. We've seen some very interesting stuff. And actually, perhaps it's interesting to go back to Hahnemann. Hahnemann had views on this, and he consistently used a word. The word he nearly always used to explain the mechanism of homeopathy was geistlich. The German word geistlich, normally translated into English as spirit-like. Which does actually slightly remind me of Mark Twain. Mark Twain, the great American writer, said, when you speak German, you're in a luminous fog. So I don't think actually saying it's spirit-like gets us anywhere. But that's the word that Hahnemann always used. So anyway, that's enough of that. Let's talk a little bit. So you saw this one the other day. These are the questions we're going to look at here. Oh, aren't we? No, we're not. Sorry, something's gone wrong with the animation. Okay, so what we're looking at here. So, sorry, that's supposed to come up, but there's something wrong with that. So can substances diluted beyond the Avogadro limit have effects in living systems, and how might any such effects be mediated? And I suppose in the Nordic countries you call it Avogadro, not Low-Schmidt. I don't know, there's a big split in Europe. German-speaking countries call this Low-Schmidt's constant. And actually Avogadro invented the principle, Low-Schmidt calculated the number. So, And Low-Schmidt gets very complicated because he was born in Bohemia, which at that time was part of the Austro-Hungarian Empire and is now part of the Czech Republic, and he spent most of his life in Berlin. So the Austrians, the Czechs, and the Germans all claim him. Anyway, so let's have a look. Okay, so this question of vital reaction, this is, of course, you will find in Hahnemann, very important in Hahnemann. And it is, one of these ideas that is, that most scientists, this is vitalism, this is anti-scientific. It is not. So high dilutions, we believe, trigger the secondary reaction. Again, you'll find the secondary reaction very clearly in Hahnemann without the primary reaction. So hormesis, hormesis is a very important concept and a number of linked concepts. Hormesis, I'll show you in a moment. Hormesis is simply the beneficial or stimulatory effect of a toxin, of a low dose of a toxin. By definition, the primary effect of a toxin is negative, is bad. But in low doses, very frequently, in fact, probably more frequently than not, possibly universally, they have stimulatory effects. And then there's a number of hormoligosis means hormesis specifically in the pharmacological area, paradoxical pharmacology, the same idea, rebound effects, so a whole lot of very, similar ideas, which is basically paradoxical effects as a function of dose or time or both. And those mechanisms are known, and pre-sensitization, they have to be crucial. They have to be is crucial. This is a very interesting. Taleb is a very abrasive writer. He's great fun to read. Nicholas Nassim Taleb. He's written a book called Anti-Fragile, and he says the first thing he says. He's a very opinionated, arrogant. Actually, he attacks homeopathy in this book, but it doesn't matter. He attacks nearly everybody. And he says this word anti-fragile. He invented this word because there is no concept, the concept doesn't exist. It is more than robust. Robust means it's resistant to stress. Anti-fragile means actually strengthened by stress. Interesting book. He's entertaining, very opinionated, arrogant, but intelligent man. He's an economist, basically. It's worth reading. Now maybe we have it right. This is the one I was trying to show you before. Okay, so these are the ones we're talking about. Okay, now this is hormesis. Just to show you graphically some examples of hormesis. So it's a stimulator or beneficial effect from a low dose of a toxin. The opposite one is the linear. The important thing is linear, and there may or may not be a threshold. That is not fundamental. So what you see here, this, for instance, is the effects of chlordane, the insecticide chlordane, on the rate of weight gain of crickets. Crickets are insects, chlordane is an insecticide, so it should kill them. Indeed, it does, at concentrations above 100 parts per million. But at a concentration of 1 part per million, it doubles their rate of weight gain. And this has been, the man to read on this is called Calabrese, C-A-L-A-B-R-E-S-E. He's the emperor of hormesis. We're going to publish a special issue of my journal, Homeopathy, next year, especially on hormesis and the links. It can occur with physical agencies. This is the effect of low-dose gamma radiation on the rate of weight gain of guinea pigs. Again, this so-called hockey stick-shaped curve. So this is the normal rate. This is inhibition leading to death. This is stimulation. So up and down. But the normal one, the dogma, is that it is linear. So this would be like that. And there may be a threshold, there's no effect below there, or it may just go straight to the baseline. But there is a big argument in the toxicological world between linear and non-linear effects, and the non-linear effects are winning at the moment. And Calabrese, just produces thousands and thousands and thousands of examples. So rebound behavior, this is the work of Marcos Teixeira from Sao Paulo on the paradoxical effects of rebound effects. This is particularly of SSRI, the Prozac family of drugs. Interesting, a few years ago, we did a clinical trial of homeopathy versus Prozac versus placebo in depression, and we had a big problem with the ethical committee who said, oh, what if your patients commit suicide? You've got to, because they're not treated. Now what we know is actually the ones who got the Prozac were more likely to commit suicide than the ones who got homeopathy or placebo. We didn't know that at the time. So, relatively rare, but more intense patient factors. For instance, teenagers are more likely to become suicidal when they're treated with Prozac, and drug factors including the half-life. Very interesting study. He's done a lot of work with other similar compounds. Many pharmacological agents he's looked at and shown rebound effects, Teixeira. This is similarity, because we should never forget, the main principle of homeopathy is not about dilution, it's similarity. Similia similibus curenta. You can have homeopathic dilutions that are not diluted below the Avogadro limit. And the question of similarity has not been very much researched. This is from Fred Wiegand. He's in the University of Utrecht in the Netherlands, good university. And it's not quite as complicated as it looks. What they did was to get these are cultured cells in a test tube, and heat shock them. They heated them to 42 degrees for 2 hours, and that kills them. Slowly. They don't die immediately, but they will die over a couple of days. And then they gave them various treatments. So this is if you like, the isopathic treatment. This is a small dose of heat shock. So after they treated them with a big dose, the 42 degrees for 2 hours, they treated them with 39 degrees for half an hour, and doubled the survival. This is arsenicum album, in fact, cadmium, the others. And what you can see, so this is a similarity, and there is an objective. This is, of course, the similarity is 100%, because it's the same. And the similarity is objectively defined in terms of the pattern of heat shock proteins. There is an objective definition here. And so it shows, as you can see, more or less a linear correlation between the degree of similarity and the effect size. So this is interesting, a very under-researched area. This is about actually the only bit of research I know in the area. But good, credible research. So just to remind you, Avogadro and Loschmidt, this is the number you have to remember. And 10 to the, and in fact, in many cases, you cross the limit much lower than that, maybe as low as 7 or 8 C. For histamine, which we'll look at in a moment, we know goes ultramolecular at 7 or 8 C. So biological models. So this is Claudia Witt again, the great Claudia Witt from the Charité in Berlin, whose Frauke was talking about her acupuncture work earlier on. So basically, this was a systematic review of in vitro work in homeopathy. And interestingly enough, they talked about stepwise agitated solutions. They never once mentioned the word homeopathy in this whole paper. Everybody knows who knows anything about it, knows they're talking about homeopathy. I mean, what on earth is this if it's not homeopathic ultramolecular? Everybody knows. Claudia knows. Everybody who is involved with this paper, everybody who reads it knows. But they never mentioned the word. The H word, we call it now in England. We don't even mention it. And they looked at the quality of the score. They found 75 publications, and 73% were effective, and this is not a mistake, it is 73% for both, including many of the high-quality ones. And these are the different models. This is the most common one. We'll look at this one in more detail in a moment. But that's the different models. And that was their conclusion. No positive result produced, which is true, just. As well, I'll show you in a minute, it's may just about be true, but it comes, in certain cases, it's very close to being reproduced by all investigators. Jacques Benveniste, the infamous Jacques Benveniste, he was a well-known French immunologist. He discovered platelet activating factor. One thing he was not well known for was modesty. He once described himself as nobilisable, meaning deserving a Nobel Prize. So he was a complete egomaniac, a very charming character, but a bit of an egomaniac. Died, sadly, 10 years ago, so nearly 10 years ago. So this is really, and the Benveniste saga was I lived through it, it was a very unpleasant affair. In 1988, Nature published a paper from Benveniste's group, and actually a multinational group, claiming that they could trigger degranulation of human basophils with very high dilutions of anti-IgE. I'll explain all that to you in just a moment. The point is that this turned out to be, as to put it politely, irreproducible. And as Alex mentioned yesterday, it was disastrous for Benveniste, who ended up in a hut, poor guy. And he didn't have that kind of personality that took well to that sort of thing. Anyway, so this is the human basophil HBDT is a well-described, well-established in vitro model of allergy, test tube model of allergy, been around for a long time. Basophils is a kind of white cell. They're in their cytoplasm. They have basophilic granules which stain blue with alkaline dyes, and these granules contain histamine. And let's not bother that. Let me show you the graphic which explains this to you. Okay, so here's a basophil. These are the famous granules, which are usually stained blue, and they contain histamine. So that's an antigen. So, for instance, if you have hay fever and you mix your basophils in a test tube with pollen extract, then they will degranulate. Or anti-IgE. So, and it is actually triggered by this immunoglobulin on the surface. But anti-IgE is a universal activator of blood. So you don't have to be sensitive to it. It will make any basophil degranulate. And this is what Benveniste claimed, that stuff in dilutions up to 60C works, and that turns out not to be quite true. However, this bit, what now follows, is true and has been repeatedly verified. So there we are, that's the degranulation. The histamine comes out into the supernatant. And what you get is a feedback inhibition loop. All right, this is simple cybernetic feedback. It's a negative feedback. Once it happens, instead of taking off, it tends to turn itself off. Simple feedback loop. However, what also happens is that the ghost of histamine does the same thing. This is histamine 16C, which seems to be the most potent. Most people find a peak of activity around 14, 15C. So this is here we are, the ghost of histamine. This is ultramolecular histamine. As I say, we actually know that histamine becomes ultramolecular around 16, 10 to the minus 16, 7 or 8C. So this is way into the ultramolecular range. There is no molecule of histamine here. And, well, it's true. This is the work. This was done by Christian Endler. He's the frog guy. We'll talk about him in a moment. But he did a bibliometric study looking at all the repetitions. As you can see, there's a couple of negative ones. And these are multi-centered. This one in particular, which one is it now? This one, I think, was 5 centers. Several leading people from the Histamine Research Society, which is quite a big society, one in Belfast, St. Laudi, who's based in Paris, Vigant in Utrecht, Manaioni in Florence, and somebody else. I can't remember, somebody else. There were 5 groups in all. They agreed on the method. They agreed where they would get their supplies from. They went back to their labs, did the experiment, and returned them blind to an independent analyst. And they have a positive result. So, mostly positive. So it's true that not reproduced by every single investigator, but by the large majority. And St. Laudi is a brave guy. I have to salute St. Laudi, because after the Benveniste affair, for one thing, he never spoke to Benveniste again, and which was Benveniste's fault. But he continued to work in this very difficult atmosphere, which for 10 years was absolutely poisonous, and perhaps a lesson for us all. He persevered, and he has been vindicated in the long run. This is just to show you that it is very specific to histamine. So this is histidine, which is the precursor, has no effect. Histamine, 16CH, does have an effect, so it's highly specific. Another one, this is another long series of experiments done mostly by a guy called Christian Dutremapouille in Bordeaux in France, looking at aspirin. Now aspirin, as everybody knows, is anticoagulant. Many people take small doses, 75 milligrams of aspirin a day for its antiplatelet effect to avoid heart attacks and strokes. In high dilution, he works mostly with 15C. It is prothrombotic. It increases clotting. And what's more, we have some insight into the mechanism. It gets a bit complicated, but what we know is that it appears to work on cyclooxygenase 2 mediated production of prostaglandin I2 in the vascular endothelium. Well, you know, if you really want to know, you can read the details. But the point is, we're starting to understand the mechanism. I don't know if we've... Yes, you've got it here. So this is just different inhibitors of different forms of cyclooxygenase, number of emboli, and believe me, well, let's not go into... We haven't got time to go into the detail. But what it suggests is that it is a COX-2, cyclooxygenase 2 mediated process. Now, this one is easier to understand. This is the work of Paolo Bellaviti, who was mentioned earlier. This is very easy to understand. So this is a standard, this is the light-dark test, standard screening method for anxiolytics, for drugs to treat anxiety. Used in the pharmaceutical, you have a compound, you think it might be a good anxiolytic. This is a quick screening test. And it's easy to understand. It works with mice. Mice are frightened, you know, if you give them, so here's a dark compartment, here's a light compartment, the mouse, here's the mouse. The mouse, on the whole, stays in the dark. They don't like to come out. Anxiolytic drugs increase the time they spend outside and also the number of times they go in and out from the dark to the light. This is a fairly obvious, simple method and well validated. There we are. So this is just to show you, so this is the time they spent in the light area, this is the number of times they go in and out. And this is gelsemium 9C, gelsemium 30C. And this is a standard anxiolytic buspirone. The effect is as great here, greater than buspirone. And what's more, we can even, yes, this is some rather nasty work done by a French guy at Strasbourg University. They got the brains of these poor rats and sliced them up and showed differences in this neurosteroid. So this is gelsemium 9C, gelsemium 5C, increased levels of allopregnanolone. So just, again, we're just starting to have some understanding of the mechanism. This is somebody I think mentioned, Christian Endler and his frogs. Christian Endler is an Austrian. He lives in Linz in Austria. And he loves frogs. He only likes alpine frogs, though. He goes climbs up an Alp, collects his frogs, and is very careful. He is very insistent that all his frogs are returned to the wild afterwards. He's a very, very humanitarian guy. So what he's doing basically is he collects tadpoles. In fact, you know what a tadpole is? The little fish that precede a frog. And he shows that thyroxine decreases metamorphosis. So Christian Endler has worked with frogs living high up the Alps. This guy, Guedes, works with frogs living in the Brazilian Amazon. So they're also frogs, they also metamorphose. Their metamorphosis is sensitive to thyroxine, but they're entirely different species. And Guedes has done some more work. I don't know if I've got it here. Oh, this is just to show you a meta-analysis of the different experiments done by Endler's group and other people. As you can see, it's not quite true that every single group agrees, but it's damn near. So this is so this is transition from 2 legs to 4 legs. And this is reduced tail. These are 2 measures. So this is Endler, this is other groups. And this is interesting, this is only with the alpine frogs. This does not include the Brazilian frogs. And this is Guedes. This is another one, actually, which came sent afterwards, after this table I just showed you. This is actually a slightly Frankenstein experiment. Guedes is not so humane. He cut the tails off these tadpoles and cultures them. These are living tails cultured. It's slightly Frankenstein experiments. But he showed that he's looking at apoptosis, right, programmed cell death, and showed congruent results. In other words, that, whoops, yes, there we are. The apoptotic index is increased in the test group, in the group receiving thyroidinum. Another one also not very pleasant, but a big, and big implications if this is true. These guys, interesting Iranians, working in Canada. The biggest, the most rapidly growing place for homeopathy in the world now? Iran. Would you believe it? I didn't know there was homeopathy in Iran at all. But now I keep getting papers of somewhat varying quality, I have to say, but some very good ones. This guy is now back in Tehran, but was at this time in Canada. And so they cut the sciatic nerve, leg nerve of these rats, and showed, so this is the control, they didn't cut their nerves at all. This is the ones that were just left, and this is the ones who were treated with hypericum. Big difference, and that is, if that is really true, if that can be transferred to human surgery, that is a very interesting and useful result. And, oh yeah, I think I'll skip that one. Physical research. Okay, so now we're turning now to what Lionel and Alex were talking to us about earlier. So this is no longer biological models, this is using physical instruments. So these are the experiments of the late great Louis Ray. Louis Ray was a very interesting guy. He was an Arctic explorer in his youth, and later on became a big expert in this method called thermoluminescence. Okay, so what you do in thermoluminescence is you get your sample and you cool it to 77 degrees Kelvin, so that's roughly minus 200 Celsius. That's even colder than Tromsø in January. It's actually the temperature of liquid nitrogen. And then you bombard it with X-rays or gamma rays, and what happens is that you bump the electrons out of their quantum ground state, and then as you warm it up, they fall back into their quantum ground state and release a photon as they do so. And this is a very sensitive method for looking at the structure of water. So he looked at, so this is 15C of lithium chloride and what we call natrium muriaticum. And just to show you the results, so this is the total thermoluminescence, how much light came out. So this is, they work actually with heavy water, because dideuterium oxide, this is heavy water. It's actually not hydrogen, it's deuterium, which is hydrogen with an extra neutron in its nucleus. Apparently it gives a cleaner signal. There's a technical reason for using it. And as you can see, a big difference in the total thermoluminescence. So that just means shaken water. They did shake it, but they didn't put in the sodium chloride or the lithium chloride. That's just to show it. So here they're heating it up. This is 70 degrees Kelvin, so it's roughly minus 200 Celsius, and they're heating it up to about minus 50 Celsius. And this signal, if you're an expert in the field, you would recognize this signal, I'm told, as being the signal of lithium. So the signal is weaker, but the same signal is present. And what's more, it is sensitive to the atmosphere in which you do it. So this is what happens if you do it in an atmosphere, if you do the succussion. In an atmosphere of pure oxygen, this is normal atmospheric pressure. This is half an atmosphere. This is reduced. It says vacuum. It's actually not a vacuum. It's a partial vacuum. It is reduced atmospheric pressure. So the effect gets less, which suggests, as other work also suggests, that gas bubbles have something to do with it. Nanobubbles, very, very small bubbles of gas, have something to do with it. This is Jean-Louis de Mongeat, who's an admirable guy. He's done 25 years. He's been working away, keeping a very low profile, but generating a large amount of data. So this is a large series, and he says that you have stable supramolecular structures involving nanobubbles. And this is, okay. Let me just show, this is his latest work published only this year in Homeopathy. And to my knowledge, this is the first time that anybody has been able to discriminate between different homeopathic medicines in ultramolecular dilutions. So here we have, this is plain water. He calls this manganese lactose. This is SL. SL means silica lactose. So this is what we would call silica. He calls it silica lactose because, of course, it's triturated in lactose to 3C. Manganese, saline, and histamine, all in 15C. So he can discriminate. He can tell, not routinely, but he can tell in a large enough series of experiments what was in there, what ghost is in there. And he's using, Lionel Milgrom is a much greater expert on NMR than I am, but he's using 2 relaxation times. He looks at T1 and T2 relaxation times, which are the times that the molecule precesses and releases its energy. So he's looking at the T1 and T2 relaxation times. If you want to know the details, ask Lionel Milgrom. Now, this is interesting. We were talking about nanoparticles. This is a work done by a very high-powered group in Mumbai, in India. This is the Indian Institute of Technology, a very, very good group. So they just went and bought samples of these homeopathic remedies in ultramolecular dilutions, looked at them by these, high-tech methods, and found that there were particles present. Oh, wait a minute. Here we are. Sorry, I'm slightly out of order here. Wait a minute. Yeah, so they found that there were particles, small particles present, which shouldn't have been. And the explanation they offer is this. Sorry, I'm slightly out of order here. That it is a surface phenomenon, that actually you get concentration of the particles at the very surface, and that they aspirate, that when they take one to the next dilution, they take it from the very surface layer, which is unusual, but this is their explanation. This is published in Langmuir, which is a very high-impact, very good chemical journal. So that's the explanation. That's how they explain that there are particles existing in these very high dilutions. But what for me is really interesting is that they showed for the first time. You might think doing that is a fairly innocuous process. It is not. It releases extremely high energies, very localized and very brief, but very high energies. So you get temperatures in the region of 5,000 Kelvin. So Kelvin, of course, is absolute zero, so it's Celsius minus 270 degrees. So that's hot. Pressures of 1,000 atmospheres for nanosecond periods. Very small, very brief, but very violent processes. And what happens is that the collapse of these nanobubbles generates shock waves that shoot these particles around at high energies. And then the melting, so they're melted and then cool at an inconceivably rapid rate. I mean, that is just 10 to the 10 Kelvin per second. That is very rapid cooling. And you can see it. This is zinc. Anyway, this is zinc, actually. The melting point of zinc is 600 and something Kelvin. So we can see that it has melted, that it has been subjected to a temperature in excess of 700 Kelvin, and probably much in excess, actually. This is, sorry, there's something missing here. Never mind. Silicates, we talked briefly, Birgitta raised the issue about silicates and plastic tubes. This is the work of John Ives in the Sam Early Institute in the States, who did a quite simple, amazing experiment. I'm amazed nobody's ever done this before. Showed a huge effect that nobody else seems to have suspected existed, just by storage. So they just compared this stuff, acetylcholine esterase. This is a fairly simple enzyme, standard laboratory enzyme, and they stored it for 24 hours in plain water, in water 30C made in polypropylene tubes, and water made in borosilicate. So these are good quality lab glass. This is good glass. And look at the difference. So after 24 hours, there is nothing left in plain water, nothing left in water made in plastic, and a lot of activity in potentized water. And they even share. You can even see the time course. It hardly drops off. A huge effect size. And, you would have thought this has really actually got nothing to do directly with homeopathy. You would have thought somebody would have noticed this before, but apparently not. And that is one of the silica particles. They can actually see the silica particles, and these things turn out to have very elaborate structures, very interesting structure. That's the size, that's 5 microns. And so they can show. So they mix it with water glass. The effect is the same as 100 micromolar water glass, roughly. So they can show this effect is due to silica, and the silica is leached out just by this process of succussion. And of course, it's not surprising when these very high energies are being produced, it has big effects. And Lionel, as I mentioned earlier, did some classical work showing that a very elaborate theory invented by a man called Comte was all because he used the wrong kind of glassware. So finally, there's 2 theories. Okay, so the classical one, the most widespread one, is the memory of water. But there is also this thing of quantum entanglement. Einstein never really believed in it, and he called it spooky entanglement at a distance. I wish I could remember. The German is wonderful. But anyway, so in English we say spooky entanglement at a distance. And it has been proven to work. There's no argument about it. It does happen at the microscopic level. The conclusive, or some of the conclusive experiments were done by a guy called Alain Aspect, a French physicist. It certainly happens. It is a reality. There's no argument. The question is, does it happen at the macroscopic level? This is just the memory of water. And we now have 3 different groups who are saying that there are supramolecular structures. The main difference is in their estimate of the size. They vary from, I think it's, in fact, Montagnier who says 4. Then, very recently, a guy called Vittorio Elia is estimating them to be about 100 nanometers in diameter, and Demangeat is somewhere in between. So we have 3 independent groups using different methods, all saying there are supramolecular structures, but varying in the size. So this is, yes, so Lionel has talked to us about that. But what interests me is that Lionel wrote a whole series of articles, and I finally said to him, Lionel, you've got to propose a test of this, or I'm not going to publish any more. And we never did publish any more, I'm afraid, Lionel. However, recently a test has been proposed by a guy called Francis Beauvais, who was actually one of Benveniste's original collaborators. Very simple test, so it's based on the Mach-Zehnder experiment. So this is what happens is, this is this thing that I think it was Alex was mentioning. It's as if the particles know you're looking at them. If you know they're looking at them, they trick you. If they don't know you're looking at them, they behave in a different way. So this is when you're looking at them, when you're observing with path detection. You're actually looking at them to see which way they're going, and you get 50% here and 50% here. If you don't look at them, you get them here and here. So what he is suggesting is actually conceptually very simple, that the entanglement in RCTs of homeopathy is, well, maybe, if you want to know if it's a quantum phenomenon, what you have to do is localized randomization, what he calls in situ randomization. So you don't have a central code done by a computer and sent to you. You just have a little, very simple, it could be a very simple, I mean, it could be actually as simple as this. That's a random process. But probably in practice you would have a small electronic device, very simple electronic device, which would randomize and would be on the desk of the practitioner. They would do the randomization and would also record the results, but not linked to anything else. Important that it is not linked to the internet, it is not linked to anything else, it is completely isolated, and records the results in a way that cannot be altered afterwards. It's not a very complicated device. But the randomization would be done in situ by the person, with the patient in front of him, there and then. And he says that if entanglement is occurring, that would stop the entanglement, and you could test it. So you can actually test if entanglement is occurring. I mean, this is only one interpretation, but it is interesting and it's feasible. It could certainly be done. Like everything, it's easy to talk about it in theory, more difficult to implement it, but it certainly could be done. So let's just skip. So just finally, the main points: vital reaction. We talked a little about some of the animal models, ultramolecular dilutions, original substance silicates, gas bubbles, organized domains, memory of water, which is now testable. The quantum entanglement is now testable. And sorry about the commercial. Thank you for listening. As you will notice, Birgitta stole my logo.
Thank you very much. Any questions? Or shall I say questions, please?
Very interesting indeed, but how does this affect my everyday practice in my clinic? I sometimes buy in the pharmacy distillated water in plastic bottles. sometimes I'm lazy, I'm on the move, I'm taking water from the tap to dilute my pills, shake it and give it to my patients with a few drops of alcohol. Will that affect the actual outcome of my remedies, depending if I'm using the desalated water from the pharmacy? They've been sitting on the shelves next to all these allopathic medicines.
No, I think the answer is nothing in here suggests that that would have an effect. What it's about is how it was prepared, and it should be prepared in glass. And of course, there's interesting implications. Maybe we should be making these things in an atmosphere of pure oxygen. Maybe they would be more potent. That seems to be a theoretical implication of Ray's work. But, you know, that is a possibility. But I don't think, storing them I don't think is a problem, but I think it does seem they have to be made in glass.
But the water itself is sitting in these plastic bottles on the shelves next to other allopathic medicines.
Nothing that I've shown has implications for that.
Right.
But I think the implication is that they should be made in glass.
Any questions? Am I right if I want to dynamize this, you know, I tell the patients to before you take the next dose, shake the bottle, and then you mix a few drops with water before the intake. Now, will this dynamization happen if I use plastic?
Probably it appears not. It appears not. We think not. Actually, one very interesting thing that I didn't put in here is the work of Elia, who says that using fairly basic, simple physical chemical tests, says the effect gets stronger. And he's observed these things over 300 days. And he says the effect gets stronger, and it is due to dissipative structures. Dissipative structures, you can imagine a hurricane. So these are structures that are far out of equilibrium, out of energetic equilibrium with their environment. So a hurricane obviously is, you know, very violent process going on in a relatively calm. They're constantly exchanging matter and energy. So obviously it is not the same molecules of air. It's constantly moving. And what else? What's the other characteristic? One other characteristic of... anyway, those are the main things. So they're far out of equilibrium, and yet they're stable and they go on. And that includes hurricanes. It also includes us. We are way out of equilibrium with our environment, and we are constantly exchanging material. And his explanation for why the effect gets stronger is that there is some kind of dissipative system, some kind of system that is way out of equilibrium with the surrounding things, but is actually self-sustaining and can actually get stronger. Hurricanes can get stronger and stronger.
Thank you. Questions?
Hi, thanks, Peter. It was really good. You always manage to get so much in a talk.
too much, yes.
But just to hammer on that point about glass, and what we kind of touched on earlier, is that Demanja also showed that he could use plastic if he used lithium chloride, so solutions of lithium chloride, and then if he used plastic, it still had a signal. So it seems it's just there needs to be some form of impurity for the structures to form, rather than, and it seems to me that it might not be any specific type of impurity. It might be the air, or it might be silica, or it might be whatever. But so that's what I got from Demanja's.
Yeah, possibly. Yes. Well, the truth is we don't know. We do know that there are nanobubbles of gas and silica nanoparticles, and probably others. But the truth is we don't really know beyond that at this stage.
Thank you very much. Thank you.